I think the eucalyptus is one of the most magnificent trees. Did you know that it began its journey around the world from Australia? And then there are these tiny cloves. They started out from Indonesia. Nowadays, they are used as spices around the world. Both eucalyptus and clove oils have characteristic smells. Do you think chemistry has something to do about it? Keep thinking. Hello and welcome to another episode of Chemistry with me, Debabrata Goswami. Today, we will be talking about the compounds with a pleasing smell. Today, we will look at ethers. This will include their preparation and chemical properties of ethers. And at the end, we will have exam decoded where we will tell you all that you need to know to max your scores. Seems like we have a lot to cover in today's episode, but as I always say, it's good to begin at the beginning. So what are ethers? Well, ethers are organic compounds which are formed by the substitution of a hydrogen atom in a hydrocarbon by alkoxy or aryl oxy group. If you remember, in the beginning, I had left you wondering about the reason behind the aroma of clove oil and eucalyptus oil. No surprises. Chemistry is at work here as well. Clove oil contains an ether called eugenol, while eucalyptus oil contains eucalyptol. It is because of the presence of these two ethers that the oils have that special smell. Let us now take a look at preparation of ethers. Ethers can be prepared by using two different techniques: dehydration of alcohols and Williamson's synthesis. We will first look at the dehydration of alcohols. Alcohols are dehydrated in the presence of protic acids like sulfuric acid and phosphoric acid at 413 Kelvin to form symmetrical ethers. Recall that symmetrical ethers have identical alkyl groups on both sides of the oxygen atom. They are represented by the formula ROR. You need to remember three things about dehydration of alcohols. The first and the most important point is that dehydration is used only for the preparation of symmetrical ethers. Secondly, the reaction temperature must not be raised above 413 Kelvin. When the temperature becomes 443 Kelvin, alcohols are dehydrated to alkenes. So you must be very careful with the preparation of an ether. For example, at 413 Kelvin, ethanol dehydrates to give ethoxyethane. But at 443 Kelvin, ethanol dehydrates to ethene. The presence of a protic acid is necessary for this reaction to take place. Thirdly, unless an excess of alcohol is used, alcohols undergo dehydration to yield alkene. I hope you will remember this. But you can always log on to www.topperlearning.com to refresh your memory. It's time for me to take a break. But tell me, is the preparation of ethers using alcohols a unimolecular or a bimolecular reaction? Keep thinking. There is a lot more on the other side of the break. I'll be back in just a bit.